All right, so you already started the problem. What kind of questions do you have like as you've started? I would say probably one of your questions was the right decision to make the u value 10x squared. Yes. The way I choose my u value is kind of the order of most complicated to least. The most complicated situation for me in this problem is the 10x squared is causing me issues. I want to get rid of it. That's my first instinct. If there's nothing in parentheses or nothing set apart, kind of like it is as an exponent, my next step would be, well, what is the hardest thing to deal with? So during class today, we talked about one that had sine and ln in it. I don't like that, so I wanted to get rid of the ln part so that I just had trig to worry about. Because trig is a little bit easier in the grand scheme of things than dealing with natural logs in the middle of an integral. So for this particular problem, you make your decision. You say that you're going to start off with u as 10x squared. Make sure that you have everything for your du. Your du in this situation needs to be 20x dx. Ah, my bad. Got him. There it is. 20x dx is what I need to use for my du. And so I have 5x from it and the dx already, but I need to bring the times 4. That makes me have to put a 1/4 on the outside to cancel it out. So that blue stuff is stuff that I manufactured. If I have to manufacture something inside of a U substitution, that's okay. It's not a huge deal. From there, I'm going to go ahead and switch out all that stuff to make it the letter U, which should hopefully make it feel a little bit simpler. Like that's what the goal was. Is that I'm getting rid of all the X's in the problem. All of the X's in this problem should disappear because I'm going to replace it with a U, which makes me feel better. This is what that's going to make it look like. 1/4 stays on the outside, but now on the inside, it should just be 6 to the U du. Antiderivative of 6 to the U is 6 to the U over the ln of 6. I still have this 1/4 on the outside, and one of the most important things is to make sure you have the plus C. You forget the plus C, you leave points on the table. Go for it. The 4 and the 5x is embedded. All of this stuff right here is embedded inside of that du. All of this is already there. When you put in du, you took all of that and said, hey, I'm just going to check. You do not need to make it 5/4 on the outside. If you do make it 5/4 on the outside, that means you only have 4 on the inside, and you needed 20. Your other option is you could have like took the 5 out, but then multiplied in a 20 and a 1/4, or in a 1/20. Would have been the same thing. You would have gotten to the same place because that outside fraction would have reduced. So Anjali, if you want to keep on taking the 5 out, that's completely fine. You can. Just notice that it when you had 20 over or 5/20, it's the same thing as what we have too. Thoughts? Are you done? You have to do anything else? No. That's all. And so that's where we come to our question that we discussed a couple days ago with changing the boundaries. If since this is an indefinite integral, I have to put in the u no matter what. But if it had boundaries, I would be at a crossroads. Do I really want to plug back in 10x squared, or could I just leave it? If I choose to leave it as the letter u, I need to make sure that my boundaries are in terms of u instead of in terms of x. I am never going to tell you that you have to change boundaries. It just adds a couple extra steps. So it's your choice though. If you're confident in your ability to plug numbers in and to do the algebra that would allow you to keep track of everything, once you've plugged in the number, keep it that way. If you can do problems like that, you should be getting a B on the test. That I mean, it's not an easy problem by any means. I don't think this is a very straightforward thing to talk through, but it did require you to know your integral rules, which most people don't know. It required you to do a U substitution, which is what the entire chapter hinges on. We only did two other types of problems in this chapter besides the U substitution. They were cross section, and we briefly, very, very briefly, talked about the average value of a function. That's okay. It was so brief, like it was like half a conversation. It was like in the middle of something else. So I'm gonna give you another example about that in a second. You want to talk about this absolute value one? Important thing for absolute value is that you need to make sure that you are dealing with things, sections that would always be positive. This graph is what we normally would deal with, but this section in the middle has to flip upside down so that the graph of the absolute value of x squared minus 9 really looks like a W instead. So that's the whole idea. That's going to happen. That's why it flips up. That's why we're actually talking about the red one instead of the green one. It should be pretty obvious. Yeah, I would say it should be pretty obvious. So in this one, I gave you the function x squared minus 9 because it's a really quick factor. You know it's got to be at 3 and at negative 3. So I'm going to do the integral until I get to negative 3. Then the next one, I'm just going to use a subtraction on it because I want to make it negative, going from negative 3 to positive 3. And then finally, I'm going to add back in from positive 3 to positive 4. Your other option is to make it positive on this one in the middle, but to negate the entire function on the inside. That would be the same thing. This one is different because it has two zeros instead of just one. Well, that would mean that you never cross back into the positives again. Since I cross back into the positives at positive 3, I need to separate it again because it goes back to the original rule of x-intercepts. Correct. You had one on the last test too. See, that sounds awesome. Find the zeros. Anytime there's absolute value, you should find the zeros first. Correct. After you find the zeros, you should rewrite your boundaries. Rewriting the boundaries in this situation, I used those zeros to do it. I changed it to negative 3 in the middle. So I have this space. That middle section, like you were just saying, I want to negate the sections that were negative. The reason why I have a negative here is because I want to negate this entire section. It was supposed to be down here on the original graph, but that absolute value makes it so it has to flip up and everything is on the positive side. It only does that in between the space from negative 3 to positive 3. Once I get to positive 3 again, I'm back to normal. So I found the zeros, I rewrote the boundaries, I negated the sections where x was, or where the y value was negative, and at that point you evaluate. It is a lot of algebra. I think that's the most difficult part about AP Calculus is not actually the calculus that's involved in it. It's the algebra that you have to do to finish the simple calculus process. You never took Algebra 1? It's okay. I've taken Algebra 1 like 9 times. I teach it every year. I enjoyed Algebra 1. Everybody loves the quadratic formula. Let's see that.
Math doesn't really treat you like a child. It's just math.
Love Deb too, but she made it. I think she made it all the kids a lot harder. Oh my god. Okay, you know what? Everyone knows my AP scores. This is only fair.
Let's find the average value. Okay. So average value question. This is, like I said, it was a really, really quick conversation. I'm not sure if we ever wrote it down in the notes, so it's actually good that we're doing it here. I would say it is fair game because it is such a simple concept. Yes, it is in the book. Here's what I'm going to tell you. Start at 2, end at 5. I gave you a function. What does that function do here? Like, what is the actual purpose of an integral? What else does it do? It's the opposite of velocity. It's antiderivatives. It's the area under a function. It's the accumulation of a function. That's the one we always forget, the accumulation of a function. That's telling you if you started at some y value, this is how much you're going to add over time. This is what is getting added onto where you started this function calculation. If you started at 7, you do this integral, it's going to tell you where you ended up at the end. It's telling you how much space you actually put on top of it. And so the idea is if this is the total, and I know it's got to be the total because of the actual integral itself, that's the total amount of change that's taking place. The average just means that you would divide it by how much space there was. So an average says we add everything together, aka a total, divided by how many things there were. So I'm going to take the total area and divide it by the interval across you went. That's going to give you like an average height. Hey, love Riemann sums. You want to do a Riemann sum? I would say a Riemann sum should be like your bread and butter. I would say that I will never let you forget a Riemann sum. If you don't remember anything about calculus for the rest of your life, you should remember the phrase rate of change and how to do a Riemann sum. You've done enough. I would say any type of Riemann sum that I give you from this point on, they're all the same. It's just a matter of making sure that you use the right points. I'm not going to record one on the video, but I can talk you through the one that's in the packet. We still are.
I knew how to factor. I didn't get a 3 on it. Okay, so.
I don't know how well it's picking up you guys' voices. That's it. Yep, that's it. So the one that was in the packet this during class today, it said, here's the average value. It's 33. For this one, it would be times 1/3. For the one that was actually in the packet earlier, it was, I said the average value is 33. So we set this whole thing equal to